Imagine peering into the cosmos and witnessing Earth's ancient past, a time when colossal dinosaurs still roamed our planet. But how far away would an alien observer need to be to see a Tyrannosaurus Rex stomping across the globe, right now? When we gaze into the universe, we are inherently looking backward in time. This phenomenon occurs because light travels at a finite speed, meaning we perceive objects not as they are at the precise moment we receive their light, but as they were when that light was first emitted. Once light departs a planet, a star, or any other celestial body, the information it carries is fixed and cannot be updated. Furthermore, the greater the distance of an object, the further back in time we are observing. Light travels at an incredible speed, approximately 300,000 kilometers per second. This remarkable velocity means that light could circumnavigate Earth's equator in a mere 0.13 seconds. Consequently, in our daily lives, this delay is entirely negligible. Technically, everything you look at is seen as it was a minuscule fraction of a second ago. This, looking back in time, effect only becomes truly noticeable when we observe objects in space, and even then, it requires the immense distances of deep space to be impactful. Consider the Moon, our closest astronomical neighbor, situated about 384,000 kilometers away. This distance translates to approximately 1.3 light seconds, meaning we see the Moon as it appeared 1.3 seconds in the past. The Sun is roughly 8 light minutes away, so we perceive sunlight 8 whole minutes after it leaves its surface. As a crucial safety note, you should never look directly at the Sun with unprotected eyes, as it can cause severe damage. However, if observed with specialized safety glasses, you would see the Sun as it was 8 minutes ago. This implies that if the Sun were to vanish right now, we wouldn't know about it for a full 8 minutes. It's quite a thought, isn't it? What's truly fascinating is that this principle works in reverse as well. If intelligent life existed elsewhere in the galaxy or universe and possessed the means to observe Earth, they would not see our planet as it is today. Instead, they would witness Earth as it was thousands or even millions of years ago. No extraterrestrial civilization would be aware of our modern lives for a very long time. You and I exist only in their future, if they exist at all, of course. This naturally leads to the question, how far away would an alien observer need to be to look at Earth and see living, breathing dinosaurs roaming its surface? Surprisingly, and perhaps a little frustratingly, this question has a relatively straightforward answer, at least in principle. The last non-avian dinosaurs perished when an asteroid, several kilometers wide, collided with Earth approximately 66 million years ago. Therefore, if there were aliens situated 66 million light-years away, or even further, and they possessed an exceptionally powerful telescope, they would indeed observe dinosaurs dominating our planet. Simply stating, 66 million light-years away, might feel a bit circular and not entirely satisfying, so let's explore what that truly signifies and the immense scale of these distances. Remember that a light-year is a unit of distance, not time, despite its name. It represents the distance light travels through space in one full year, and it is an incredibly vast measurement. 1 light-year is equivalent to 9.46 trillion kilometers, an absurdly large distance. When we then discuss millions of light-years, it gives you a true sense of the gargantuan distances involved and how far one would need to be to currently observe dinosaurs. To grasp these colossal distances, let's journey outwards from Earth, selecting a few planets, stars, and galaxies along the way. We'll consider how these locations might be viewing Earth if they harbored life forms equipped with telescopes. As we've established, the Moon is 1.3 light seconds away, so hypothetical astronauts on the Moon could, in theory, see you with a delay of just over a second. And any hypothetical fire-based life on the Sun would perceive you with an 8-minute delay. Pretty cool, but not yet mind-blowing. Let's skip the other nearby planets, as they are also relatively close. Neptune, the most distant planet in our solar system, lies approximately 4.5 billion kilometers away. This translates to a light travel time of about 250 minutes, or just over 4 hours. Thus, Neptunians would see you eating your breakfast while you were having lunch on Earth. While Neptune is billions of kilometers away, we are barely scratching the surface of looking back in time, for ours is insignificant when aiming for millions of years. So, let's venture out of our solar system. The next nearest star to us after the Sun is Proxima Centauri, located 4.16 light-years away. Any Proximans, as I'll call them, would see us as we were 4 years ago. Now, things are starting to get interesting. Think about how much you've changed in the last 4 years. Yet, those Proximans would perceive you as you were back then, younger, hopeful, and perhaps full of dreams. That said, we are still a long way from seeing dinosaurs, so let's zoom out even further. Here, centered on the Sun, we can use a magnificent map of nearby stars. Let's pinpoint one of the most distant named stars visible, our good friend Betelgeuse, or Betelgeuse as it's often pronounced. This famous star is approximately 642.5 light-years away. This means anyone living around Betelgeuse would view Earth as it was around the year 1381. At that time, Richard II was King of England, the 100 Years' War was raging, with no one knowing it would last for a century, and America was still about 400 years from its formation. This is fascinating, but it's becoming clear that we need to travel an immense distance to reach our ultimate goal. Now, we can envision the entire Milky Way galaxy. The diameter of our home galaxy spans about 100,000 light-years. Anyone situated on the opposite side of the Milky Way would see us as we were 100,000 years ago. That was the era when the very first modern humans were emerging and migrating out of Africa. Earth was undoubtedly different back then, but the dinosaurs had already been extinct for nearly 66 million years. The Milky Way contains between 100 and 400 billion stars, yet none of them can observe dinosaurs. Our next significant stop on this journey is Andromeda, the closest major galaxy to us. This galaxy is roughly 2.5 million light-years away. Now we're truly getting somewhere. This time period predates modern humans, but our ancestors, Homo habilis, had diverged from apes and chimpanzees and lived in very simple shelters. Earth was on the brink of an ice age, and immense megafauna like woolly rhinoceroses, mammoths, and cave lions roamed the planet. To reach our target of 66 million light-years, we still need to go considerably further. We must zoom past countless other galaxies, each containing billions of stars and planets that could, in theory, host alien astronomers observing an ancient Earth. If we journey out to our magic number of 65 to 66 million light-years in a particular direction, we arrive at a beautiful galaxy named NGC 3972. This galaxy was famously imaged by the Hubble Space Telescope in 2015. Like the Milky Way, it contains billions of stars, and it's highly probable that the majority of these stars host multiple planets. Therefore, theoretically, if intelligent, telescope-building life existed on one of those planets, they could be witnessing Earth with the last dinosaurs still alive, including the world's most formidable scavenger, the T-Rex. It's also intriguing to consider that we are seeing NGC 3972 and its stars as they were 66 million years ago, meaning they too will have evolved and changed significantly since then. It's captivating to ponder what might be hidden within that image and how it has transformed over the last 6 million decades. Even with this bold claim, a few important caveats exist. Firstly, in reality, building a telescope large enough to resolve Earth in sufficient detail to see dinosaurs from such an immense distance would be virtually impossible. To actually discern animals on the surface, they would realistically need a resolution of about 1 meter or so, and achieving that over these distances is effectively beyond current technological limits. Even with simplifying assumptions, a telescope dozens of light-years wide would be required to achieve anything close to this resolution, which would undoubtedly present engineering challenges beyond imagination, even for very advanced civilizations. So, while fun to contemplate, it's not truly realistic. Secondly, in my assertion that they could see dinosaurs, I am neglecting the motion of this galaxy, which is influenced by gravity and by dark energy pushing it away from us. This means that although NGC 3972 is 66 million light-years away now, it wasn't always that far from Earth in the past. Space itself is expanding, carrying galaxies with it, and this alters the calculation somewhat, making it more complex. That's why I've simplified it here, but it's an important consideration if you were to undertake this calculation yourself. It's slightly mind-bending, but you would need to calculate which stars, planets, and galaxies were 66 million light-years away exactly 66 million years ago. Then, you could project the universe forward in time to determine where that galaxy is now, which would be significantly further than 66 million light-years. However, that adds another layer of complexity that I will also set aside for this discussion. Beyond all this, it's interesting to remember that dinosaurs lived when Earth was on the other side of the galaxy relative to our current position. The Earth, Sun, and our entire solar system are not at the galactic center. We actually reside about 26,000 light-years from the center, within a spiral arm called the Orion Arm. This means we orbit the galaxy slowly but surely at 828,000 kilometers per hour, completing one full orbit approximately every 230 million years. This roughly implies that dinosaurs lived when our planet was on the opposite side of the galaxy to where we are now. While this doesn't directly impact the light travel time for imaging purposes, it's a fascinating detail to consider. Finally, even disregarding all these caveats, NGC 3972 and its potential inhabitants wouldn't be able to see all dinosaurs. Many famous dinosaurs died long before the asteroid impact. There was an incredibly long period during which dinosaurs dominated Earth. For example, Stegosaurus lived between 150 and 155 million years ago, during the late Jurassic period. To find a planet capable of observing them, we would have to look to a galaxy like IC 1776 and hope for aliens residing there. As a fun aside, the time difference between living Stegosauruses and living T-Rexes is about 80 million years, which is longer than the time difference between living T-Rexes and us. The earliest period with dinosaurs, called the Triassic period, began approximately 250 million years ago. Incredibly distant galaxies, such as NGC 547, would be able to witness the very birth of dinosaurs, observing creatures like the chicken-sized dawn raptor. Even beyond this, countless more distant galaxies exist that could theoretically perceive Earth in a pre-dinosaur state of infancy, with even earlier planets and massive insects. We know of so many galaxies that are more distant than any of these numbers, and it's truly captivating to imagine how they might view Earth, or even the cosmic dust from which we eventually formed, before we were even a planet.